So in part 3 of our lesson 6C, we're going to be talking about our power of a product property. So what this means is last time it was a little bit different because we would have some exponents in here and then we would have the extra exponent out on the outside, and we will do some like that. But notice with our other examples that we did on our part 2, there was only one thing going on in here. There's just an 8 or just a -5 or just a -3. There was just one thing going on with the base. Well, here, there's going to be more than one thing happening with the base. The base is not just x, it's x and y, or x times y. So this is the biggest difference between our part 2 and our part 3. So we're going to, again, these first 2 examples, we'll write them out just to see what happens, and then we'll see what kind of shortcuts we can use. Okay, so when we're doing xy to the third, that's like doing xy times xy times xy, and I know it's written different, but notice all of this is being multiplied, okay, because x times y, this is being multiplied because when they're side by side, it's multiplication, and then using these parentheses side by side, that's also multiplication. So remember, with multiplication, you can move around everything. You can jumble around the order. So I'm going to bring all these x's up front and put all these y's behind it, and when I do that, I'm going to condense this and just write it using exponents instead of repeated multiplication. So I have 3 x's, so that gives me an x to the third, and then I have 3 y's, so that gives me y to the third. Okay, and then I can't do anything there. Always check for 0 exponents or negative exponents, but we don't have anyone, or we don't have any of those there, so I just have my final answer is x to the third, y to the third. Okay, same thing here. Let's multiply it out, see what's happening. You got 5xy squared, so it means you got 2 of them. I'm going to rewrite it and put the 5's in front. Then I got a couple x's. Always go alphabetically. Then I got some y's. Okay, now I'm going to condense this. I know 5 times 5 is 25. I have 2 x's. I have 2 y's. So there's my final answer. Okay. All right, so what you'll notice is happening with these is when you have a product as your base. So right now our base is some product, either x times y or 5 times x times y. When you have a product and you're taking a power to that product, what we do is I kind of think of it like distributing. That exponent of 3 goes to each of those variables or numbers and variables, whatever's inside parentheses, it kind of distributes to both of them. Same thing here. It's going to distribute to both of them. So this is going to be 5 squared x squared y squared, and then you just fix your 5 squared to be a 25. Okay, so you kind of think of it like, you can draw in some arrows if you want to, but you kind of think of it like distributing that exponent to each of the things happening as the base or inside the parentheses. Okay. All right, so let a and b be real numbers inside your parentheses here. These are real numbers, or they can be variables, and then let m be a positive integer. So this up here is just a positive integer. Whenever that happens, to find a power, they kind of rewrote it like this. So you basically just take this m, whatever the exponent is, and you bring it to both a and b. Okay, so to find a power of a product, find the power of each factor. So these inside, these are factors. And multiply it out. Okay, so we just take this m up here, we bring it to each of these factors, and we just write it as a to the m, b to the m. Okay, all right, let's try number 1 here. So you're taking this squared, you're moving it here, you're moving it here, you're moving it here. Okay, so when I do that, I have a squared, b squared, c squared. All right, go ahead and try this next one. So be careful when you move your squared to each of these factors in here. Make sure you keep this -3 together, and then you've got your a squared. So go ahead and simplify that a little bit more and check to see what you get for that answer. If you want to pause the video and then play it once you've got your answer. All right, so I know -3 times -3 is a positive 9, so I end up with 9a squared. Okay. And then lastly, for number 3, this one's different because the negative is on the outside, and then you're doing 3 squared and then a squared. So keep that negative on the outside. So I know 3 times 3 again is 9, and then I have an a squared. So the difference between those two is if the negative is outside like that, you got to keep it out there on the outside. Okay, so if the negative is outside parentheses, keep it outside. If the negative is inside parentheses, you keep it with that -3. Keep it with the integer next to it. Okay, all right. Lastly, the problem with this is they did not distribute that exponent to the factor of x. So it should be x to the third instead of just xy to the third. All right, and then the other part of this, part 3, is just doing the same thing. Some of them are simplifying and some of them have some scientific notation problems for us. For this first one, again, you just take this exponent and you bring it to everything. We're going to kind of bring back what we just learned from part 2. So we have 3 to the 4th times x to the -3rd to the 4th. Okay, so we do 3 times 3 times 3 times 3, which will give you 81. And remember, when you have a power to a power, so a -3 to a 4, and the -3 is already an exponent, we multiply them together. I know -3 times 4 is going to give me -12. Okay, keep in mind you cannot have negative exponents, so we need to fix this. We can't have 81 times x to the -12, so to turn this into a positive exponent, we put 81, and then we put that x to the 12th at the bottom, and it is now positive. All right, so make sure you got that answer for example 4. Okay, and again, always fix it. If you have negative exponents, make sure you're fixing them. And then with your scientific notation, it's the exact same thing. So you're still just taking this exponent out here, and you're moving it to each of the factors inside. Okay, so I'm going to zoom out here so I can write this a little bit better. So we're doing 5 to the -3rd times 10 to the -2 to the -3. Okay, so that's another power of power 1. All right, so when we take 5 to the -3rd, we cannot have a negative exponent, so I'm going to write this as 1 over 5 to the 3rd. Okay, and then once we do that, it's times 10 to this right here. We just multiply these together because, again, it's a power of a power. -2 times -3 gives me a +6. Okay, and this doesn't look very nice for a final answer, so I'm going to simplify this part of it. 1 over 5 to the 3rd. If you put that in your Desmos, 1 over 5 to the 3rd, you get that, so 0.008. Okay, so this right here gives me 0.008 times 10 to the 6th. We can't leave it like that because our exponents are all messed up. Or, sorry, not the exponent, but this is not scientific notation. You got to fix that guy. So, to figure this out, you can always just rewrite it to see what you get in standard form and then turn it back into scientific notation. So, in standard form, if I have this, and I move this decimal 1, 2, 3, 4, 5, 6 times to the right, I end up with 8,000. So we just have to turn 8,000 back into scientific notation. So to do that, my decimal's here, move it 1, 2, 3 times. Okay, so you're basically getting rid of 3 from the exponent. So you're really taking away 3 when you move this 3 times to the right. So this ends up giving us 8 times 10 to the 3rd. All right. Great, let's try one more of these that has scientific notation, and you can do number 6 if you would like to. I'm going to skip here to number 7. So for question number 7, again, you take this exponent out here, and you bring it to both of the factors inside. So bring down your 10 to the 4th. Okay, we have a 2 to the 4th now, because we're taking this and bringing it here. And then I'm just going to do this in the same step. I have a power to a power. So I'm going to make this -2 times 4 is -8. So I'm going to write it like this. Okay. All right. Then from here, I need to do 2 to the 4th, and you can put it in your Desmos or just multiply it out. That should give you 16. And I now have these two terms to combine together or to simplify. So it's 10 to the fourth times 10 to the negative 8. Okay, when they're like that, we add those exponents together. So you're adding this 4 plus this negative 8. So you multiply them when it's like a power to a power. But when it looks like that, when it looks like 10 to the fourth times 10 to the negative 8, that's where you add them. So we add those two exponents together. When you do that, you end up with 10 to the negative fourth. Okay, and then we got to fix it. We can't leave it like that because this number is not in scientific notation. That's got to be bigger than 1 but less than 10. So it's too big. So you can write it out. 16, 10 to the negative 4 would mean I take this decimal, move it 1, 2, 3, 4 times to the left. Okay, so this would be like adding in 2 extra zeros, but I want to get it back into scientific notation, so move it 1, 2, 3 times. Okay, so I end up with 1.6 times 10 to the negative third. And again, if you remember your trick, like when I do this, I add, or when I do that, I subtract, you can use that, or this is going to work every time. Just move it into standard form and then turn it back into scientific notation. That way you don't have to try to remember, am I supposed to add here or do I subtract? It'll just make it a little bit easier. All right, there we go. 1.6 times 10 to the negative third. And again, if it's scientific notation, you're fine to leave the exponent negative, but if it's not scientific notation, we'll have to fix it. All right, and then the last one we will do together, let's go ahead and do number 8. And you're welcome to try number 9 if you'd like to, but let's go ahead and try number 8. So Billy has a pile of mulch delivered to his house, and it's in a pile in his driveway. The pile is shaped like a cone. The height of the pile is 3 feet, and the radius is written in scientific notation. It's 2.1 times 10 squared feet. You can always move this into standard form, but since it's in scientific notation, we'll just leave it like that. They want us to find the volume of that pile. Okay, so to find the volume, we're going to start with their volume formula that they give us. So they say volume equals 1/3 pi. And then the radius here, they're saying is 2.1 times 10 squared. Let's use that for your radius. Times the height, and they tell us the height is 3. All right, so all I did is I took this and I plugged it in here for the radius. And then I took this, the height, and I plugged it in here for the height. Okay, once you do that, let's simplify everything that we can simplify. But I forgot one thing. The radius needs to be squared. So I need to squeeze a little squared in here. I'll scoot this over. All right. So it's 1/3 pi r squared h. Here's my 1/3, my pi. My radius is this, but you have to square it. And then here's your height. Okay, from here, let's fix some things up. So first thing I want to do is fix up this scientific notation. So I have 1/3 pi. Remember when it's an exponent out here, you bring it to each of the factors. So we have a 2.1 squared times a 10 squared, but you do 2 times 2 to make that 10 to the fourth. Then you do that times 3. I know that taking 1/3 times 3 is just going to give me 1. So those cancel out. Those are gone. So my next step, let's go ahead and multiply 2.1 squared, and you can just do that in your Desmos again. So 2.1, and then there actually is a squared button here. So you can just push that squared button, and you get 4.41. Okay, so my volume right now is 4.41 times 10 to the fourth. Okay, so that's this simplified. We don't have this 1/3 or 3 anymore, but we do still have pi. Okay, so whenever they ask for an exact answer, this would be it, and then its volume, so let's label it feet cubed. So if they ask for an exact answer, it would be this. And then if they want a rounded answer, just kind of depends on what they ask for. If they want an exact answer, you would say 4.41 times 10 to the fourth pi, and you always put this pi at the end. If they want an exact answer, let's figure out what that would be. So 4.41, let's see, so 4.41 times 10 to the fourth gives us this, and I need you to do that times pi. So find the pi button. When you do that, you get 138,544, and then let's just round it to the nearest tenth, so we'll call it 0.2. Okay, so another answer you could say, let's use the about, because it's an approximation, because we're rounding, 138,544.2 feet cubed. All right, and feel free to try any of the problems we didn't get to, and then I have the completed notes posted so you can check to see if you got them correct. As always, please ask questions if you're stuck on any of our lesson 6C, which is all about properties with multiplication. So our exponent rules when there's multiplication, and then we'll get into division next. But feel free to ask questions or shoot me a Canvas message if you ever have any questions.